How can you reliably update the database and also publish a message to the queue? Well, you can't, at least not reliably, and this is where the Outbox pattern comes in to solve this problem. So let's jump into the video and I'll show you how we're going to use it. The best way to understand this problem is with a good example, and that's what I'm going to show you here. We have two services, the Orders API and the Shipping API. Inside of the Orders API, we have a few endpoints, and the one that we are interested in is the post endpoint for creating a new order. Inside of it, we're going to create a new order instance, insert this into our database by opening up a database connection and running a SQL query. And then we're going to create an order created integration event and publish that to the queue using mass transit, but you could use any other library for publishing this message. And then inside of our shipping API, we have the order created integration event consumer. Here, we're going to create a shipment for the order based on this message, and then somebody will process this order and call a respective endpoint on this service to update the shipment status to shipped, for example, completing the workflow. Now let's go back to our initial example with creating an order and publishing a message. This doesn't really have to be a message publish operation. We could be communicating with any external component inside of our system. This could be another service, this could be a third-party API, and the overarching idea is that we don't have a single transaction spanning the entire operation. The insert into our database is one transaction, and this is an all or nothing operation. So it's safe from a side effect perspective. We're either going to insert this value into the database or we won't insert anything at all. But when you introduce another operation, this is no longer transactional. We could end up in an in-between state where we have the order successfully stored inside of the database, but we fail to publish a message. And how do we recover from this? Well, let me show you how this works in practice. I'm going to start the application. And if I open up Docker Desktop, you can see that I have my services running. We have the Orders API and the Shipping API. These are the .NET applications. And then we have a Postgres instance, which is our database, and a RabbitMQ instance that we are going to use for messaging. Now, if I jump into the Swagger UI and try to create an order, and the values here don't really matter. I'm just going to insert a random quantity and total price, and then let's send this request. And we're going to land on the breakpoint in the Orders API. And here we're going to create an order instance, open a database connection, and then insert this into the database. And at this point, the order is now persisted inside of our database. Our transaction is complete, and then we will proceed to publish this message using mass transit. So I'm going to go past this line, and we're going to complete this publish, and I will press continue. And in the background, mass transit is going to consume this message in the shipping service or the shipping API. And you can see that we land on this breakpoint in the order created integration event consumer. So now I'm going to create a shipment, insert this into the respective database of the shipment API, and then we're going to complete the flow. So I'm going to press continue. And then here I will get the order ID, which I can use to fetch the order from the Orders API. You can see that this data is persisted in our local database, but I can also use it in the Shipping API to filter out the shipments for a given order, and you can see that I get a shipment back where the shipment status is pending. So what I can do is send a post request to the ship endpoint, and this is going to update the status to shipped. And if I try to query the shipments for a given order, then I'm going to get the shipment with the updated status. So everything seems to be working as expected, right? But not quite. So let me try to simulate a failure of our message broker. So let's go back to the post endpoint. We're going to send the same request to our Orders API. So let's hit execute, and I'm going to land on this breakpoint. So let's go ahead and insert this into the database. So this completes, and now I'm going to open up Docker Desktop, and I'm going to manually stop the RabbitMQ instance to simulate some downtime. Now, if we go back to our application and attempt to publish this, we're going to run into an exception because our broker is unavailable. And you will see that this is pending because it's retrying to publish the message to the queue, but eventually it's going to time out and fail. And this is how our system ends up in an inconsistent state. So we have the order present in the database, which we can confirm using the identifier of the newly created order that I copied from the database. So if I send this request, you can see that we do get this order from the Orders API. However, if I go to the Shipping API and I specify this order ID, I don't get anything back because this order hasn't been published as created because our message queue was down and we weren't able to process it in the shipping API. And this is exactly where the problem is. So this is the same piece of code that I just showed you for sending a post request to the orders API and trying to insert an order and publish a message. Now everything works fine in the happy path where all of the services are available and all of our external communication with the database and the queue completes without any issues. However, we could run into a situation where the database insert fails, and this is also alright because we're just going to revert the transaction and we won't store anything in the database. We also won't publish anything to the message queue. Now, the problem happens when the database insert completes successfully, which you can see in green here, but the message publishing fails, which you can see in red. And I repeat again, we can replace the message publishing with any external communication. So this could be a third-party API, another service, a different message broker, or even another database. But the problem is that we can't create a global transaction to span both of these services, and implementing two-phase commit to solve this is something we want to avoid. So an alternative solution is implementing the Outbox pattern. So here's what the updated code will look like once we are done with the changes. And what you will notice is that instead of publishing a message to the queue, we now have something called an outbox message that we are inserting into the database. And now everything is part of the happy path. In other words, this entire request can either succeed and everything is stored in the database successfully, or nothing is going to be persisted and we are good either way. The part I want you to focus on is this part here, where you can see that we are opening a database transaction because we have two separate requests or two separate queries. The first one is inserting the order into the database, and you can see I'm explicitly passing the transaction here, and then we're going to create an order created integration event and insert that to the Outbox messages table. This is also part of the same transaction that we're going to commit right here, and then we can return from this endpoint. So let me show you a sequence diagram of how our flow is going to change. So when somebody wants to submit an order, we're going to open a database transaction with our database, and then we're going to insert the orders and the Outbox message as part of the same transaction that we're going to commit and return to the user. And then in the background, we need another component, which I'm going to call the Outbox processor, and is going to select the unprocessed messages from the database. And let's say the database returns a batch of messages, and then we're going to publish them to our queue one by one or in a batch, whichever you prefer. And then we're going to mark these messages as processed inside of our database so that we don't publish them again. And the benefit here is that our initial operation of submitting an order is now completely transactional. Either everything gets stored in the database in an ACID compliant way, or nothing is stored in the database, and then we can retry sending the request to the API. On the other hand, we do have an extra component, which is the Outbox processor, but you will see that we can make this reliable. Now let's go back to our code and see how we can implement this. So inside of the orders API, I'm going to add a new folder that I will call the Outbox. And in the Outbox folder, let's go ahead and add a new class that I'm going to call the Outbox message. So I will make this internal and sealed, and we're going to need a few properties on this class. So the first one is going to be a GUID value, which is going to represent the identifier. Then I'm going to need to store the type of the message that I'm going to serialize into JSON, and that's why I need the type property. And let's also make this required. But I will need another property that's also going to be a string that's going to represent the serialized JSON content of the message that we are trying to publish. And then I will need a few helper properties. So I'll need a datetime property for when this message occurred. So let's call this occurred on UTC. And I'm going to create another property that's going to be nullable, and I will call this processed on UTC. So let's add that. And then I'm going to add one more string property representing my error that I'm going to store if processing fails for some reason. So this is my Outbox message. Now I'm going to need a respective table in the database, and I already prepared the SQL statement for this ahead of time. So I'm going to copy the query from my SQL script here, but you can see that I'm just creating a table called Outbox messages, and it contains the columns that match the properties that I have on the Outbox message class. The one interesting thing I'd like to highlight is the use of JSONB, because I'm using Postgres under the hood, and this is a more efficient format for storing JSON data because it allows indexing and processing based on the contents of the column. So we're going to now paste this into my database initializer. So when I start the application, this is going to execute and create the respective table. So I'm going to close this down. And the next thing I need is a way to insert the Outbox message into the Outbox messages table. So I'm going to create an extension method on the IDB connection class, and let's call this the Outbox extensions. So I'll make this internal and static, and we're going to need an async method that's also generic, and let's call it insert Outbox message. Let's pass in the generic argument, and then this will be an extension method on the IDB connection. The next argument is obviously the message that I want to publish, and I'm also going to add support for passing in an optional transaction, although it shouldn't really be optional. However, for the sake of simplicity, let's make it an optional argument. I'm also going to add a not null constraint on the generic argument, and then let's implement our method. So what I want to do is create an Outbox message. So let's initialize the Outbox message type, and I'm going to set the ID to our random new GUID value. The type will come from my message, and I will call the getType method and use the full name. Then I'm going to get the content using the JSON serializer from system text.json, and this is a very efficient way to serialize your objects into JSON. And then for the occurred-on property, let's use datetime UTC now. And these are all the values I need to insert an Outbox message. Let's also rename this to be single instead of plural. Then I will need my SQL query that I'm going to paste in to save us some time, but this is just an insert statement into the Outbox messages table containing the identifier type content and the occurred-on column, and we're going to fetch these values from the Outbox message instance. And then we can say await connection, execute async, and let's pass in the SQL query. The parameters are going to be the Outbox message, so we're going to pass that in, and of course I'm going to pass in the transaction as an optional argument. And this completes our extension method that we are going to use from the post endpoint when we are creating the order. So now, instead of publishing the order created integration event, let me comment this out. We can even get rid of the iPublish endpoint that we are injecting, and instead we're going to insert this into the database. So I can say await connection, insert Outbox message, and pass in the order created event. However, this isn't part of the same transaction. We have two round trips to the database, so we want to make sure that they are in the same transaction. And you can use the existing connection to open a new database transaction. So I'm going to call begin transaction async, and then I will pass the transaction to the two requests that I'm sending to my database. So now both of my round trips to the database are part of the same transaction. However, I also need to commit this transaction once I'm done. In case of any failures, the using statement will go out of scope and dispose the transaction, and is going to be automatically rolled back if I did not successfully call the commit method. So we don't have to explicitly do that inside of the endpoint. So this takes care of one part of the equation. This is creating the Outbox message instead of publishing an event. However, we also need to process this Outbox message in the background and then publish it to the queue. So I'm going to paste in a new class called Outbox background service, and this is going to be our background service that's going to execute an Outbox processor every few seconds, and inside of the Outbox processor component, we're going to implement our actual logic. As for the code inside of the background service, it's really nothing too interesting, so I didn't want to spend too much time on writing this from scratch. We're just executing the code inside of a while loop until we are requesting the cancellation or when the orders API is stopping, and then I have a delay after processing the Outbox for a given frequency. We could also fetch this value from the application settings so that we can make it configurable, and you don't necessarily have to make this a background service. You could use something more robust like Quartz or Hangfire, whichever you prefer. I'm just showing you how to implement the actual Outbox processing. How you're going to execute it is an entirely different matter. And the interesting part here is that you can completely decouple this from the orders API. This could be a separate process that we run for processing the Outbox. So you would just grab the background service that we have here and run it separately. So let's go ahead and register this as a hosted service. So I will say builder services add hosted service, and I'm going to specify the Outbox background service. And we are missing just one more component, which is the Outbox processor. So let's go ahead and add a new class called the Outbox processor. and I'm going to make this internal and sealed. So what do we need here? I'm going to inject two services, the MPG SQL data source, so that I can open up my database connection, and the iPublish endpoint from mass transit so that I can publish the messages. Then let's go ahead and create a private constant that's going to represent the batch size. This is how many messages we're going to process at one point in time. And then let's create a method where we are going to actually process the Outbox messages. I'm going to call it execute, and it's going to accept a cancellation token. So what needs to happen inside of the Outbox processor? The first step is fetching unprocessed messages. Then step number 2 is going to be publish these messages. And step number 3 will be update messages in the database. However, I'm going to merge these steps 2 and 3 as part of the same flow. So let me show you how we're going to implement this. We first need to open a database connection, of course. So I will say data source, open connection async, and we can also pass in the cancellation token. You can even use await using here because we are calling an async method on the other end. Now we also need a transaction. So I'm going to say await connection begin transaction async, and then we can go into the next step, which is actually fetching the Outbox messages. So this is going to be a query, and I can use Dapper. So I will say connection query async, and I'm going to specify the Outbox message type as what I'm returning from the database. Then for the actual SQL query, I need to say select star, or I could be more specific and just fetch what I need, but let's keep it simple. Now I'm selecting from the Outbox messages table, where the processed on UTC column is null. But it's also important that I sort these values based on the occurred on column, and the default sort order is ascending, which means we're going to get the oldest messages first, which is what we want. And then I'm going to limit this to the batch size, and we're going to pass this as an argument. So let's go ahead and pass in the batch size, and you can also pass in the transaction because we already have it. The transaction will be important when you want to scale this out to have multiple Outbox processors. Now I'm going to call the extension method from Dapper called asList so that I can have a list of Outbox messages here. Now that we have the Outbox messages, I can go ahead and iterate through an individual message and then execute these steps that I need. After the loop, I'm going to say await transaction commit async. We can also pass in the cancellation token, and then let's return the Outbox messages count as the number of messages that we processed. And then I'm going to add a try catch statement because I want to handle any exceptions that I get here. And what do I want to do in the body of my loop? The first thing I need is to actually extract the message type. And I can do this by using the assembly reference of the project where my message contracts are. And this is the messaging contracts library. Inside of it, I have a static class called assembly reference, and this is just a helper class to help me get the assembly. So I can say messaging contracts assembly reference and grab the assembly instance. This is just a static field, and then I can say get type, and I need to pass in a name for a type that is part of this assembly. And as you can guess, this is the type property on the Outbox message. So now that we have our message type, I can use the JSON serializer to deserialize an object, and I'm going to pass in the content from the Outbox message and the message type. Let's assume that this can fail, so I'm going to use a null forgiving operator, and this is going to be my deserialized message. So now that I have the deserialized message, which is going to be some integration event that I want to publish, I can say publish endpoint, publish, and pass in the deserialized message. We can also pass in the message type and the cancellation token to make it easier for mass transit to publish this message, but then we also have to update this inside of our database. So let me paste in the query that I want to execute, and this is just an update statement on the Outbox messages table where the identifier of the row is the ID of my outbox message, and we're going to set that we have processed this message at the current UTC now time. So this is our happy path. But we could also run into an exception, and in that case, I want to also update the outbox message by running a similar update statement, except this time I'm also going to pass in the error, which is going to contain the exception as a string. A few alternatives you have here. You could retry publishing the message a couple of times and only then give up. You could implement retries with poly and create a simple resilience pipeline that you are going to use to execute the publish step. But eventually, if you do fail, you need to give up on processing this message for at least a period of time. Now, how you implement the retry mechanism is up to you. You have a lot of flexibility here. However, the implications of this on your consumer are very important. This means that you could publish a message more than once. And this is really important when you are using the outbox pattern. You have to be aware that yes, this does give you a more reliable way to publish your messages, but the delivery semantics that you get is called at least once message delivery. This means that we can guarantee that we're going to publish a message once, but we can't guarantee that we won't publish this message more than once. So we have to implement idempotency on the consumer side, either by storing the message ID and checking if we have already processed it, or some operations are naturally idempotent. You can explore this topic separately. I also made a video in the past that I'm going to leave in the description below, which you can check out. Now let's go ahead and register this with dependency injection as a scoped service because I'm using the publish endpoint. So I'm going to say add scoped, specify the outbox processor, and we are ready to give this a try. So with our outbox processor running in the background, let's go ahead and create an order. I'm going to specify some random values and then execute this request. And we land on the breakpoint in the orders API. So let's open up a database connection and a transaction, and then we're going to insert the order into the database. And this completes successfully. Now I'm going to go into my extension method, create a new outbox message, and also insert that as part of the same transaction. And only when I complete the commit async method, this transaction is going to complete, and we will have both the order and the outbox message inside of our database. So I'm going to hit continue here, and we will land in the breakpoint in the outbox processor. You can see that if I check the outbox messages list, we have one outbox message containing the order created integration event that I just added to the database, and we're going to try to deserialize this, which we do successfully. And then let's go ahead and publish this using mass transit and insert this into the database. Now, because my shipping API is running concurrently, I'm also going to land in the order created integration event consumer, which is a good thing. And now I'm processing this message as part of the shipping service and inserting the shipment into the database. So this is also going to complete, and I'm redirected back to the UI where I can grab the order ID and go into the Swagger UI for the shipping service and try to look for the shipments for this order. And you can see that I do indeed have a shipment present here. Now I can go ahead and try to actually ship this using the shipment identifier. So if I specify this correctly, I should be able to ship this order. And if I refresh this, we're going to get back the shipment with the updated shipment status. So I want to make a few more remarks when it comes to the outbox processing step. We already mentioned how you could make this more reliable by introducing retries into the message publishing, but this also means that you will have to make your consumers idempotent. Now, because most message queues work with at least once delivery, your message consumers should be idempotent to begin with. So let's assume that you already have this in place. The second thing you want to think about is archiving your outbox messages table. Let's say every day or every few days, depending on your volume, you go into the outbox message from a different background job and clean up any processed messages. Another thing you might consider is having a sort of a dead letter queue for outbox messages that you aren't able to process after a few attempts, which could mean that you have some larger issue at hand. But typically, if you're just publishing these messages to a queue, this should really succeed without any issues. And one more thing I want to discuss is how you can scale the outbox processor. And actually, this is going to be part of the next video that I'm going to publish. So you can consider this a part of a series on the outbox Outbox, and if you enjoyed this video, then go ahead and smash the like button and subscribe to my channel. And if you want to learn how you can scale the Outbox pattern to process billions of messages per day, then you should watch this video next. Check out my courses to improve your software architecture skills, and until next time, stay awesome.